I'm Martin. I'm from Vienna, as I already said. I'm self-employed consultant. And hopefully we will sort out those things. Okay. I think it works now, doesn't it? Yeah. Okay. And yes, I want to tell you a bit about events, commands, and long-running services. And I have kind of that role today. Bernd is also a very good friend of mine, I have to say. I have kind of that role to introduce you to more concepts, which fits to my personality anyway. I'm doing quite a bit of work in the domain-driven design area recently. I've also been speaking at several conferences in the last year. So if you're interested in the kind of things I'll show you, then just check me out and you will find a bit more. I want to speak about commands and events, compare them a bit, and make that in a, yes, also quite specific context of long-running services. So, what are long-running services? I associate that here with a tree, in the sense of such a tree needs a bit care. We need several steps over some time in order to deliver value at the end. And this is actually a quite good correlation to what we see on an organizational basis. In order to deliver real value to some customer, you typically need several steps to achieve that, not just one. And we're so much used to thinking in terms of atomic steps and transactions when we are creating software. So that might be an issue in that area. And something else that is actually quite well known in the area of business processes, enabling business processes in microservices, architectures, are those patterns, orchestration, and choreographies. I also want to speak about those patterns a bit and compare them. So, really just a few fundamentals. What is an event? Well, Greg Young. Who knows Greg Young? Okay, quite a few. He's a quite well-known person in the domain-driven design area. Again, is doing event sourcing and kind of coined that CQRS term. And he says an event is something that has happened in the past. So we have some historical fact, something happened in the past. And now we can inform others about it. Like the payment is retrieved, we cannot change that fact anymore. We could, of course, pay the money back, but that would not change that we collected money in the first place. So that is kind of that reasoning here. Whereas on the other hand, it's often that commands look into the future. So a command specifies something that should happen in the future. It did not happen yet. One can, when we look at what Jonas Bonnet, creator of Acker, says about that, one can even more see that pattern, because he says commands are all about intent, so I intend to do something, whereas on the other hand, events have no intent at all. So one could also associate commands with intent and events with kind of outcome in that respect. And I try to depict that as a sort of to-do on the left-hand side and some completion of that to-do in a success case on the right-hand side. That outcome, of course, doesn't necessarily have to be a success. Now, when we look at commands and events from that perspective, we also could come to the conclusion, actually quite easily, I think, quite obviously, that commands and events are like two sides of a coin. So we have intent, like we want to retrieve that payment, then we are doing that, we are carrying it out, we have the payment retrieval, that execution in between, now it happens, and then we have that successful, in that case, outcome, in the simplest case, and in the hoped for case, the payment is retrieved, so that would be the event. What disturbs us sometimes when we look at something like that is that we probably already kind of feel that this payment retrieval is not necessarily an atomic step. So it's not necessarily carried out in one step. But it's still a kind of execution. I want something, and there comes some point in time when I achieve that. So this is already hinting in that direction of long-running services, long-running logic, a long-running execution in between. We could, of course, also flip that coin and say, this also works the other way around. I can react to an event in the environment and can then say, okay, I want to do something about that. So in that case, we would have the payment retrieved as a historical fact as a starting point, and then we come up with a new intention. Now we want to fetch the goods. Once we have the money, we actually decide we could now go to the inventory and fetch the goods. So who would do that? Probably somebody else. So we would have a different responsibility, for example, like the order fulfillment. Somebody who is in charge of, when we now look at that more from an organizational perspective in the first place, somebody who is in charge of order fulfillment would like to decide that the payment is retrieved to fetch the goods. An observation I want to make, and I think it's especially also the case in the microservices community, but it's also the case in the domain-driven design community, they are connected, of course, is that recently we are discussing events much more than we discuss commands. So I think actually this is a cool and good development because we overemphasize definitely the command and control principle. It's also from a even not just organizational perspective, maybe even in our societies. And this, of course, there is a relationship to what we see in our architectures and how we build systems. So it's a very good thing that we are now looking into events and how can we enable more high-level collaboration by leveraging events. At the same time, there is, of course, a danger that we overemphasize again. I think it's just starting. We call it events first microservices now. There is a danger that it's going in the direction of events only eventually, and I want to discuss that also. Events are really cool. I just want to point out a few aspects, not dig into them really deep, but just to trigger some associations. We can already use them or use them in workshop formats like event storming. You might have, do you already know about event storming? Do you have heard about it? A few, so it's a workshop format that is focused on events in the first place. We have a timeline, kind of. We are using sticky notes to model a business process. Very rough one here, an order is placed. Until the customer is happy, we need to achieve some facts on the way, so we can depict those facts as events, use such orange sticky notes here, and try to sort out what is that process actually all about. So this is how this might look like when it kind of starts to get interesting. So it's still a big picture exploration here in the very first step. You see a lot of orange sticky notes, they represent events. You also see a few blue sticky notes, they represent commands. So you also see a certain imbalance eventually. We are very much focused on events here. Events are also cool to do things like separate write and read models, we call that. So we would have a service, let's say, or maybe just an object, an entity within our monolith even, doesn't matter at that point, which would be responsible to say, okay, I'm retrieving the payment now, that part would publish an event like payment retrieved, and we would now be able to check that event onto some other structure that's actually prepared just to serve a read purpose, like an order summary, which would also have a paid or not yet paid flag, for example. So we would like to have that information in that order summary. So the moment the user requests that an order summary, this is readily available, I could say. So this is basically what the command query responsibility segregation, CQRS, is all about. And we can easily imagine that we can also do that across services, so that that payment retrieval aspect might be a separate service in that example, and that other aspect of actually showing the current status of the order with the read model might be a separate service, so that order summary would now leverage kind of a foreign event, and we could really decouple the non-functional requirements we have for those services. So this is of course a big upside. Payment service doesn't even have to be up when the order service delivers that order summary, including the paid flag. We are using events even for persistence purposes nowadays. Event sourcing does exactly that. So not representing structures anymore to persist things, but actually persist events. And when loading such an event-sourced entity, it's then possible to reconstruct current state in memory. So it's also much easier to change that structure. Our main topic is how can we leverage events, or what about long-running processes? So of course, we can use events to enable whole business processes, because the moment we have something like the payment service here, which is publishing payment retrieved event, other services can build upon that and can say, I'm not just using that for read models like we just saw it, but I'm using it to trigger further actions. So the moment we do that, we get kind of chains of events because the payment was retrieved. That notification service, which might also maintain a user configuration. You want to be informed about this and that, but not about this other thing. And I'm now aware that the payment was retrieved for that case, and you want to be informed about that, so I'm sending out that notification to you. And I have that as a separate concern. So it's, from that point of view, no wonder, because we can do so much wonderful things with events, that people more and more say, let's just rely on events in between services. Why do we actually need anything else than events anymore? And then, when I look at just a very simple example like this one here, I have a payment service, and I have, for example, a credit card gateway, so maybe just some wrapper, which is able to say, okay, I'm really collecting that money from the credit card now. Then I have the question, if I enable all that just with events, do I really not have any contracts anymore in between services? So does that sound about right? Are there no customer and supplier relationships anymore? What about responsibility? Somebody wants something, somebody else fulfills it. Events have no intent, we heard. So there's no intent anymore in between services. Doesn't really sound about fully right to me. So when we look into that, maybe a little bit background of mine just quickly, but probably I also have those concerns, or I see them maybe faster than other people, because I have that fulfillment context very often. So I'm working in those fulfillment processes. So I'm really in things like order fulfillment, for example, in the energy trading space, fulfilling an energy trade that already has been concluded is a complex thing. And it might take a year, for example, to deliver that power at certain points, and there's a complex thing going on to actually fulfill that trade, but it's highly automated, of course, and companies reach out to automate those fulfillment things more and more. So we have also in other areas, so we have a lot of service interaction going on, and not so much human interaction in those things. So that's also a bit different. If you're interested in what I've done, just head over to my website. I am in Vienna. I'm also working time to time in Munich. So I was heavily influenced by that book, I would say. But domain-driven design is not just a book anymore nowadays. It's really a discipline, one could say, an area of knowledge, of practices, and yeah, one can see there was already some interest after that, after Eric Evans wrote that book already 15 years ago in the first years, but then in recent years it seems at least to kind of explode now, what is going on here. So a lot of books are written, it's not even all of them, I just picked the most important ones here. And this is of course also related to microservices. So at least this aspect of bounded context is often discussed in the microservices arena. So yeah, there are also a few conferences. I just want to make you aware. There is the Exchange in London. There's a domain-driven design Europe in Amsterdam. We have a conference in the US too, not so interesting for you, but we also have one in Berlin now, which is actually taking place in about 2 weeks or so, mid of October. So I'm unfortunately in Vienna, so far off everything. So I have to use airplane and to go to all those places. And yeah, do that and did that. But I'm not in that lucky position as you are in our capital. There's no domain design. So fulfillment and business process. Let's go back to our topic. I want to look a bit into end-to-end business processes and their phases. When something, there's an event again, when a new pair of shoes is ordered, then actually this is not the beginning of an end-to-end process. But there is, of course, something happening before a new pair of shoes is ordered. So when we really look at everything that is happening, then we would probably come up with something like that. There's an old pair of shoes really worn out. We look into our shoe cabinet, and maybe we even had some other such historical facts. So we really need to act now. So we decide as a potential customer to do something about that. We decide to act upon facts. So here we have a correlation again to what we do in software systems. And also the next thing is a correlation. We are now entering a kind of customer phase because now we want to find out what can we exactly do about that. And from the moment on that new pair of shoes is ordered, one can say, okay, we are now entering a different phase because now we have kind of defined what we want as a customer. So there follows a supplier-driven phase, one could say, until that new pair of shoes is really delivered. And to be a bit more specific, and this is important now, actually in between those two phases is not an event. But what's actually in between is intent. So this is what we typically associate with commands. So what is actually exchanged in between a customer and a supplier is that order. Please do something for me. I ordered a new pair of shoes. The first reaction by the supplier will of course be, okay, I accept that, probably, and now the new pair of shoes is ordered. But it's can also, from the supplier perspective, it can be seen as a kind of task again. It's a job for the supplier to carry that out now. So from a semantic perspective, this is clearly intent. We of course build software for both of those phases, and we also see those phases on very different levels of granularity. Here's a very high level, bird level view. So we have that customer-driven phase. We are exploring suppliers. We are looking at catalogs, trying to search for new shoes. So we need to build software which is supporting human beings in that phase mainly. Whereas in that second phase, fulfillment, everything is very much determined now. We have clear intent. So customer already says what he wants. So we really just need to carry it out. So in that supplier-driven phase, we see a lot of machine-to-machine interaction, and automated services are what we want to achieve typically. when we look at that second phase here, one could now already say on a very high level, bird level view, this is already kind of like a long-running service. It's a long-running order fulfillment service. We see something like order a new pair of shoes, and until that new pair of shoes is delivered, one can look at that as a kind of long-running contract. So such a long-running organizational service does not have to be a technical service, of course, but still, it's a long-running contract with our end customer. It's a long-running asynchronous contract. So here's the order, and at some point in time, I hope that I get those new pair of shoes delivered. Of course, it will take hours to weeks typically, so just want to point that out. We have that contract, but it also takes time to deliver that. We of course see those long-running services also on finer levels of granularity. And when we look at those finer levels, we of course see more internal customers. It's now not the end customer anymore. And we start to see things that look more like that could be a technical service, something like a payment service. Retrieve that payment, but it's now happening in a context, for example, in the context of an order. So we again have a kind of long-running contract between an intent, like retrieve payment, and that outcome, payment retrieved. In that case, it's interesting actually, it could even be that we can carry that out in one atomic step. Maybe we have a positive balance on the customer account, and this is really just done in one step. But it could also be that it takes weeks. Maybe we find that the credit card expired. So when this is a responsible service, which is really now trying to get hold of that money, it really sees that as a long-running contract and tries to deliver that promise. I still try to retrieve the payment, even if it takes weeks eventually. On a finer granularity, I just mentioned credit cards. Something like I charge a credit card is still a long-running service. It can be seen like that. We know, all know, as customers, that it takes seconds until such a credit card is charged, and in the background there's actually multiple transactions going on. It's not just one step that needs to be carried out. So again, we have a kind of long-running asynchronous contract in between that intent, discharge that credit card, and the successful outcome, credit card charged. Now, it's already, I think, valuable to have the concept of long-running services in mind, but still we have to ask ourselves how can such services interact with each other? We still, in a microservices architecture, we'll have a lot of services. So we know those two basic principles to enable that. And there is the choreography principle, which is very much focusing on events, and the orchestration principle, which is more working with, intent and command. So the choreography principle would go in the direction of saying, okay, a service like the order service could raise an event, the order is placed, so somebody else can do something with that information. Payment service could now say, okay, I'm starting to retrieve the payment. And when this is done, I'm raising an event, payment retrieved. So after some time, this will be done, and other services, again, can build upon that. It's a very simple example, but just to illustrate the principle, the basic principle. So we kind of see that event chain that is happening here, and everything is enabled via events, whereas in the orchestration principle, that would be different in the sense of a service like the order service, for example, could now have a more coordinating, more central role, and would now be in charge to coordinate that process. So the order service would now say, okay, I actually want from that payment service that payment is now retrieved, please, and I want from inventory service, please, I can fetch the goods, and so on. So that would be the basic difference between those two principles. Now, what I often see, actually, especially in the microservices communities, is that the story of orchestration and choreography is more or less presented along those lines. It's often said there's one main advantage to orchestration. We have that, it's really true. We have the process logic, that coordination logic I just mentioned. We have it in one place, so it's really visible there. We can look at that place and it's implemented there. So that might be an upside. And it's more implicit when we look at choreographies. So that is often acknowledged. What is then said, well, yes, but orchestration, on the other hand, actually this centralization idea, that whole idea, we actually don't want to have that in the microservices architecture. So please rather not. So this is going in a central direction and might be dangerous. And those choreographies and event-based architecture enable that decentral, high-level collaboration. So that that seems to be the better choice when we go in the direction of microservices. And then also with regards to coupling, we think in the direction of commands and request response, then services will be tighter coupled, we'll need to know more about each other, whereas with events we have that really low, just semantically coupled in between. And then on top of that, it's often said, story is already quite much going in the direction of choreography, it's often said, and this might not even be a downside, because once we have events, we can of course easily listen to them, so we can enable business process monitoring, and we just look at what is going on in between the services, so we can compensate for that missing visibility. And I kind of agree with all of that, but still I would think it's not a very good story to tell it like that. So I want to dig into that a bit. First, when we look at choreographies and say that the process logic is a bit implicit, but that might not even be a downside, there is more to that, and this is actually, it's not something I tell you, it's very well known and already described in early books about event-driven architecture, that this implicit process logic also means that it's not just a visibility problem, but it also means that we do not have one single place where we can change that logic. So this is actually something that I see relatively seldom discussed in microservices communities, because it's a true microservices concern. Because what happens typically is an accidental form of hidden coupling here. So it's actually rather easy to illustrate that. If we just want to do a thing like, let's be more friendly to the customer, and we just get hold of that good first, we go to the inventory first, and then we go to the credit card, and we know that we have that good. So we would like to change those two steps here. So we have a small change in that process logic here going on, and change the order of those two services. So what happens is we now find us changing the listener for the inventory service, changing the listener for the payment service, and thinking about it, we will also find that we have to change the listener for the shipment service too, because it used to listen to goods fetched, and now it's listening to payment retrieved. So it's really one atomic requirement. We cannot cut that any further, and we do not have that single place and that single unit of deployment to deploy that properly. So this is a concern for microservices architecture, and I would like to see it discussed more often. This kind of coupling, one has to know, I would think, is not happening in an orchestration scenario. So the fact that we have that process logic explicit also means that we have a place where we can change it. So change the order of those two services. The contract is now a different one. I tell another service what to do, so we can really change that in the order service and just redeploy the order service. There will still be, of course, things to have that we have to take care of, because we have running instances of long-running logic, but still we have an upside when we look at that requirement here. So this maybe too fast decision to say we use events only might become a dangerous one when you have more complicated, more complex process logic in between those services. When this overall fulfillment logic is actually a concern in itself, then I would definitely be cautious to just rely on events. So I would like to add a sticky note here and say in that column of service coupling, not necessarily related to orchestration and choreography. There are different kinds of coupling. We often discuss a very technical coupling and have a very technical association about what is coupling, but also that semantic coupling that happens in those event chains might be a very important one in our scenario. Let's look into that, literally central concern with orchestration. Because we end up with those central logic and those God services which suck in almost everything as a tendency. Well, the danger is of course here, but I also want to dig a bit deeper and discuss a bit that we might have possibilities to look at the topic differently too. What I often see is that we compare commands and events in a rather strange way, I would say. Rather focused on, on understandable categories, but let me show you what I mean. We say things like, okay, commands are maybe carried out synchronously, whereas events are asynchronous by nature. Okay, we say actually understandable commands, this is going in the direction of request and response style, whereas events, that is more that fire and forget style. We also, and I understand it, associate commands, this is that sender and receiver exchange of style, whereas when we go in the direction of events, we have the publish subscribe pattern, and we associate that. And we also have that association commands are probably transient. At least once they are executed, we can throw them away. With events, we associate persistence. And I understand all those associations, but I just want to make you aware, or ask you to ask why is that really something that is relevant for distinction in between commands and events? And I would like to argue actually all of that is not really a relevant distinction. So it's technically associations that are understandable. So let me ask a few why questions. Why not do asynchronous commands? Of course, it's relatively easy to conclude. Of course, it's doable. Asynchronous commanding, you might not want to do that. This is another story. I'm also not arguing here that I'm now in favor of asynchronous commanding. I just want to invite you to say, okay, this is not a proper difference in between commands and events, because I can do asynchronously both of them. So let's look at the second one, request and response. What about that? Well, why not kind of fire the command and think more in terms of listening to an event as a sort of response? So when we say, okay, this asynchronous response is actually an event, and we are listening to events like payment retrieve, goods fetched, goods shipped, well, then what we do with that command is going very much in a fire and maybe not forget in a semantic sense we are interested in that event, but in a technical sense, we fire that command. So again, this is probably not a good differentiation to think here in terms of that. What about sender-receiver exchange, the next one? Well, I mean, let's just ask, why not publish a command? It's possible. One could say, but it's not appropriate. Well, but I could also imagine some upsides. I could, for example, say, let me think, when I publish a command, then I could actually do something like, I do not even need to know anymore which service is actually carrying out that command. I have something like location transparency. In domain-driven design, we like to think in terms of semantical bounded context. We say this is a model which is using a common language, and that might be implemented with several microservices. So when the other service says retrieve payment, there might be some services in the financial services context which is actually reacting to that, and that might change over time. So that could be an upside here. Also, publishing commands could enable an even better business monitoring, in the sense of that monitoring could say, okay, I know that the other context already wanted the payment to happen, because I see that command, and the financial context, now I see it, now it retrieved the payment, because I see that event too. So I can imagine upsides, and again, it's just not a proper difference between those concepts. So let's really think in a very different direction and think about semantical differences. What is the difference between command and event? Well, we specify an intent here with a command. So this, one could say this kind of means we model our state of mind. We want something. So an intention, something needs to be done. Whereas when we look at events, we typically model outcomes. So what is an outcome? Well, this is most often something that models what is happening in the world. So it's of course more relevant to everybody, everybody's state of world, one could say, because it's not so relevant that you want something. For me, it might be relevant for me, but it's not yet carried out. So I'm more interested in events typically. And there is, of course, a certain relationship in between the two. Some events, some outcomes might be successful outcomes for an intention that we have. So we, of course, like to use linguistically imperative mood to express intent, whereas when it comes to events, we use past tense to express outcomes. And this is also something I want to point out, because in very event-centric architectures, I often see that people actually try to follow that rule, describe that event in past tense, but then they describe actually intent in past tense, which is really awkward. And we say it's an event, so we cannot make a difference anymore between the two, because everything is an event, but we still have that input going on in between our services. So I save you from that DDD lingo here. Commands are typically defined in the supplier-bounded context, and events typically in the emitter-bounded context. What might be interesting is, what I mean here is those semantics, of course, are related. So something like retrieve payment and payment retrieved is, of course, linguistically, both things are defined by financial services, not by the customer who is who actually wants to retrieve that payment specifically in a specific case. So that's a very important linguistical difference between the two. Still, I see so many people who, when I discuss it, who say, Martin, you are comparing, actually in German we say apples and pears, Äpfel und Birnen. In English it's apples and oranges, but it basically means the same. And I ask myself, or started to ask myself, why is that actually? Why is that happening? What is going on that people say to me I'm comparing apples and oranges? And I think it has a lot to do with that association. We associate commands with intent, but then we also say that intent is carried out in an atomic way, because that command is triggering an atomically executable thing in some service, and then it leads to an event and an outcome. But thinking in terms of those long-running contracts, this is of course not fulfilling the original intent of our customer. I'm ordering a pair of shoes, I want to retrieve a payment, and that my payment retrieval is placed, yes, that's fine, but it's not what I want as an outcome. So when we focus more on that long-running relationship, so that we say actually in real life, intent and outcome is not related with with an atomic step, but it's related by an execution that consists of several steps. It's a composite kind of execution. Then we might go in a direction. I'm also exploring that field, not saying I have all the answers, but we might go in a direction that is more helpful for that kind of fulfillment, long-running services topic I have here. And I'm calling that here intentionally a domain command. This is actually not a word so far. But I want to kind of point out that there is more to intent than just be able to execute something that can be seen as a transaction. What I can see here now is when I look at commands and events like that, that I actually can look at also at orchestration and choreography quite differently, because I can now say things like, actually, what that order service does here might not be that central. Yeah? Maybe it's coordinating some things in a very coarse-grained way. It's just ordering that this payment is retrieved, and after some time, maybe seconds, maybe even weeks, it's getting aware of that this happened. So it might be useful to have that kind of coarse-grained coordination in that order service, but it's not a central orchestration anymore, because a lot of the end-to-end logic is actually now happening behind the curtains of that financial context, the payment service. So a whole part of that end-to-end process. Of course, that API will not consist just of successful end events. There will be other end events. There might also be intermediate interaction going on. But what I want to say is that this is kind of a decentral orchestration pattern. And I can combine that with choreography aspects as much as I want. Because I can now say there might be other things, like, for example, we have a promotion service that is independently looking at payment retrieved events. And it's now deciding for itself that it wants to promote that customer. So that would be a mixture of orchestration and choreography. And why do I think it makes sense? It has something to do with responsibilities. Because it's really a supplier's responsibility to act on what the customer wants, on customer intent. So we see that payment service here as a supplier for internal customers. And who is that internal customer? It's, in our case, the order service. So the order service is here in a position of a customer. And it's the responsibility, the organizational responsibility of a customer to say, I want something. It's his perfect right to say that. By allowing commands, some commands in between services, we enable that we can model those kind of responsibilities. And of course, there are other responsibilities which span both phases. So something like the promotions service might say, I'm independently listening to payment retrieved, and then I decide whether I want to promote the customer. And this is actually still happening. There's still intent created and then carried out, but it happens behind the curtains of that promotion service. So it really depends on organizational responsibilities. And I would treat that story with a bit more caution, because it's really connected with a lot of technical associations which are valid, and I understand them. But from an autonomy perspective, when we reach out for services which actually reflect what is going on in our organization, so that we can independently deploy them as deployable units, we need those possibilities to play with those possibilities, and this story is therefore not my one. Of course, what's very important for me, and I think also in a microservices architecture, that we understand and see that this state managing business logic, when we think in terms of such long-running contracts, it's not a horizontal thing. It's actually happening inside of the services. We deliver that payment retrieval, and it might take several steps. So when we think about also workflow, Bernd will speak in a few minutes, when it's happening inside of such a service and enabling our delivery, I think this is perfectly fine. Also in terms of a microservices architecture. Of course, we do not want to have that as a horizontal concern. So process does not have to be horizontal. I would even say process is not horizontal. Process is vertical too. And this is actually a very good message, because we want to have vertical teams, we want to have vertical deployment units, and when we understand better that process is just delivering that business, it helps us to deliver business capability. We are asked to model services around business capabilities, and then it takes several steps to do that, to implement that. And this is what processes enable. And let's think about process as a vertical thing. I find it interesting. There is also more interest in process again. We have distributed systems, we have microservices architectures, maybe even smaller functions that are deployed independently. So also the big players, like I've, for example, Amazon Step Functions here. Netflix released a project, Netflix Conductor, Uber did something. Are thinking about that aspect again. But what I want to point out is that if you think in terms of microservices architecture, always look at how good are those tools in enabling you to see process as a vertical thing that is embedded in a service inside, and not as that horizontal technical concept. And they are for sure different in that respect too. I think I did not mention that, but a kind of common denominator when you look at those tools is that they are to a certain extent, of course one could say, also persisting commands, at least temporarily. Even that last aspect of commands are transient and events are persistent might turn out to be a problematic one. Maybe it's just the infrastructure which is taking care of that aspect for us. Still, don't underestimate state managing business logic, I would say. I just want to quickly point out what might be in between retrieve payment and payment retrieved here. We, of course, might want to charge a credit card. But then when we are in such an event storming session, we will quickly find other things, like, of course, the credit card can fail. So what are we doing? Somebody needs to update the credit card details. Well, who can do that? That's, of course, the customer. So we need something here, a UI, a read model to enable that. So that the customer can look at the account details and issue that update credit card details command. When we get aware of that credit card details are updated, we could of course now retry. So we could say we have a policy here, whenever the card details are updated, we again try to charge the credit card. So might of course also happen that the customer is not doing anything. So we do not get those credit card details. So we have a time aspect now here. If the credit card details are not updated, then we might want to react after 2 weeks. We just have to conclude that is failing. We do not get hold of the money. It might also be that we do not even need to touch the credit card. I mentioned that positive account balance, so that could be another aspect, that we actually first try to get hold of the money that we already have. Then of course we see, but it might not be enough for the payment. So either we have the full payment now here, or we still need to go to the credit card for the rest. And this is of course just the beginning of what is happening in between retrieve payment and payment retrieve. And this is a long-running process. It's a long-running service. Please retrieve that payment for me. Actually, it's not more, but of course, there is happening a lot. And because Bernd is here and will tell you about workflow, I also want to relate it a bit to Bernd's world. And I want to express a few wishes I have. When we do something like workflow in a microservices context, then I would like to see that kind of reactive business process execution. So I'm thinking very much in terms of messages and commands and events. So a process like the one I just showed might look like that in a BPMN. But I look at that as something, okay, there's an event which is kind of starting that. Yeah? Then we have a policy, one could say. We have a first process decision. What is our next step? Do we directly go to the credit card, or maybe we go to that customer account? So there might be 2 commands that we want to trigger here. And then this thing could be very passive again and kind of listen to events. So what we often see as an activity in a workflow context, I see that as falling into 2 parts. So it typically has an intent creation part, I want something, and a successful, maybe also failing outcome. And as a consequence of that, I can react again. And this is, of course, in principle, a nice thing to have such a visualization or tooling around that. But I want autonomous services, so I really want that they respect their boundaries. So such a process, again, is not a horizontal thing. It's enabling a service. So from point of view of the order service, it's really just that command here, please retrieve the payment, and then the reaction again. Maybe even after 2 weeks, the payment is retrieved or it ultimately failed. And this is actually only thing that order service would be interested in. And there's no central technical component doing everything all over the place. So I want that composition transparent commanding, what one could call that. I do not even know whether this is an atomic execution going on in between blue and orange, or whether it takes 2 weeks to deliver that result. Yeah, I want, of course, also enable flexible and local technology decisions by doing that, because it might be a nice thing to have a tooling like Bernd's in the order service, but maybe in the payment service I just want to say I want to do it differently. So I have my local implementation here reacting to events and commands, and I decide that inside of my payment service how I want to do that. Yeah, that's what I wanted to tell you. This is not the end of the evening, because Bernd will now very much go into, well, practical side of the equation, I would say, and more about that. Thank you.
Just let me know if you look very tired. I just stop talking. And I actually, it's quite different to what I do normally. So I don't have a lot of slides prepared actually. So I do most of the stuff like in code and live. And so we're pretty flexible in what we want to do. And actually, Martin already introduced that with that one slide. There's currently a lot going on in that workflow engine market, in the state machine market. I have my own slide on that, which is not a scientific thing. I basically just drew a couple of boxes where I put all these tools currently in. So what I see a lot is that if you say workflow engine, a lot of people still think about what I would say pure play BPMS. These are like the old things, like the huge things, like Pega or IBM or whatsoever. That's not really what we want to talk about today. There are a lot of like homegrown frameworks from all the big companies that, let's say, not tech vendors, but like the Netflix and co. Everybody did something at the moment in that space, which clearly shows that there is a need for that. Like Uber did Cadence, Netflix did Conductor, Airbnb did Apache Airflow, ING here in the Netherlands did ING Baker. So there's a lot going on in that space. So there seems to be a problem. The cloud offerings, Martin quickly mentioned that AWS does something, Azure does something, Google does something, so everybody's doing something. And there are quite a bit of open source workflow engines actually, which are quite interesting to have a look at. That's what we want to do today. And there are other frameworks which normally also go into that space, which makes it sometimes hard to decide where you want to go for. So for example, there are integration frameworks. Very often you will stumble upon, like for example, Apache Camel. And this is positioned as kind of a solution for these kind of things. Or also like the pipelining business is also kind of connected. So that makes it actually a very hard market to decide which tool you want to choose for. Currently, what I normally do is I boil it down to a couple of questions, like Martin talked about persistence, long run. So does it support the stateful operation? That's where normally you can rule out stuff like Camel. Does it support the necessary flow logic? So we're looking into a couple of things we want to do with the workflow engine. Can it do that? So that's very interesting, especially if you look at the new frameworks popping up. Does it support BizDevOps? I'm talking about BizDevOps in a minute. That's about visibility. You will see that in a minute. And does it scale to the extent I need that? And if you want to get my pro tip for a short list, that's very easy. There are 2 tools you should look at. So that's what we want to do today. It's totally like non-opinionated. It's very objective. No, but honestly, that's what we want to look at today. That's basically that's my background. So who am I? My name is Bernd Rücker. I'm co-founder, developer, advocate of Camunda. We're a company based in Berlin, here in Germany. We're roughly 100 people at the moment. We're growing quite fast, so we're very successful with what we were doing. We're an open source workflow. We're having an open source workflow automation platform. That's basically what we do. If you want to reach out to me, send me an email, send me a tweet, whatever you want to do. So that was basically the that's the intro, the very quick intro. I wanted to jump into the code very fast, and what I do actually since 2 years more or less, when we started a lot of discussions around the topic, is the so-called, I call it flooring retail example. So it's on GitHub. So all the code you see today is on GitHub. So you can check it out yourself and play around with it. All the tools I use are open source, so they're just available, so it's very easy to get going. And I look at the example by coincidence Martin introduced. So what I have is basically I have a couple of microservices running. For today, I do them in basically Java and Spring Boot. Who's Java? Programming Java? What else do we have? Do we have Golang here? Oh, a couple of C#. Python. Oh, PHP. Oh yeah. What did I forget? Oh, Node.js. For sure, I know. I don't want to ask that. Don't want to blame anybody for not explaining that. So for today, I use Java and Spring Boot, but I have a couple of the examples also in C# and Golang. So it's basically the language doesn't matter. And then I have these microservices we just talked about, and I have basically some flow logic within that. So I have an order service with the flow logic basically Martin introduced as well as the payment. So that's basically the setup we have. That's another way of drawing it. So if you don't like these circles, you probably like boxes like me. I like the boxes. And what I use actually in order to communicate between the services is Apache Kafka. It could be Rabbit as well. I actually don't care that much. Kafka is hip at the moment, so that's why I use Kafka. I mean, for the example, it doesn't matter. It should be some messaging there. Okay, so that's it. And then I have a monitoring microservice which basically looks into everything on Kafka so we can see what's flowing around there. That's the setup we do. Let's do that. And let me quickly show you what I have. So actually what you can see, I think that's the best view of that, yeah. I have microservices, so I have a lot of them. I started them locally actually. So what I already have is the services you have on the slide. I'll show you the implementation in a minute, but I want to go to the user interface first. And the first thing is the monitor. So the monitor shows all the events and commands flowing over the bus. And the second thing is actually my checkout microservice, which allows me to place an order. I'm a UI guy, that's the idea is the Amazon dash button, if you know that. You just press the button and then it gets something sent over. Which is also very closely aligned to what we do in the backend because we do automatic payment with the credit card details probably in your account data, which is what happens when you press the dash button, which probably doesn't happen if you check out through like a web page. So it's perfect. And I love the UI, definitely. So I place my order, and what we can see in the background that something happened. So what did happen? So the first thing is I have that event order placed that was published on the bus. I can also look into the details of the data if I want to. And then I see, okay, the first thing that happened, there was a command being sent. We're going back to choreography later on. But for the moment, it's a command, what Martin talked about, to retrieve the payment. Okay, and then obviously something retrieved the payment, that was an event, and then the next thing in the chain happens, like fetch the goods are fetched, ship the commands, and then it stops. So it's not the scroll bars at its end, so nothing else happens. That's interesting. Why is that? And let me quickly go just very quickly into the implementation. And there is, I'm currently looking in the order service. So the order microservice, I'll probably show you one thing first. Sorry. No, I'll show you that first. I played around with that for a long time to have a perfect slot. So what I do in that service, I use, that's what I said, Spring Boot. I use Spring Cloud Streams. If anybody knows Spring Cloud Streams, it allows me to listen to Kafka very easily. And then that allows me to do something like, hey, I want to listen to a certain stream of events, and I define a condition which of these events are interesting for me as a service. And then I can, for example, say, hey, I'm interested in the order placed event. That's what I want to do something with it. And then this method is basically called. I can read some payload from the order. Then I probably do some business logic because I'm an order service. I probably want to persist it. Probably not. Whatever you want to do. And then the next thing is I want to kick off that flow because now I want to control the flow of these retrieving payment, shipping the goods, and so on and so forth. And in this case, I use the Camunda engine for that. The Camunda engine can run in an embedded fashion. So if I go to what's happening here, I just say auto-wired. No, I cannot read the rest. Thank you, Eclipse. And yes, I still use Eclipse for demos, but don't worry. That's a process engine. Auto-wired. That's we have a Spring Boot starter. So if you're running Spring Boot, you can just include a library for the Spring Boot starter, and then it's started up by Spring Boot automatically. And then you can just say auto-wired. That's it. You don't have to configure a lot. And that's important for me as a start. It's very lightweight. If I have a problem I want to solve with a state machine, I just use it. I don't have to start up something complex somewhere. So I just have the workflow engine. And then I can kick off instances. And that's what Martin briefly mentioned. He said he wants to have reactive workflows. And that's basically how BPMN is built. So BPMN, not sure who knows BPMN as a language. Some of you, half of you probably. BPMN looks like this. This is the workflow I want to start now. So what you can see is I can react to messages basically, which can be events. And these messages have names. So in this case, it's an order placed event. Order placed event. So I named it exactly the same as I have the event on the bus. So I can just correlate the message I get with that message name. Probably attach a bit of data I want to have in the workflow later on. And then that's it. That's the only thing you need in order to kick off the right workflow instance. Then this one is kicked off, and the first thing it does is it sends out a command in order to retrieve the payment. How is that done? So in the Java Spring Boot way, I could just attach Java code. If you're in C# or Golang, that works a bit differently, but it's the same principle. You basically attach code, which in my case is very easy. It basically probably reads a bit of data from the workflow instance, and then it sends a message or a command to Kafka. And this is, again, a Spring Boot abstraction in order to send that message. Retrieve payment, payload, that's it. Not much more. And the next thing you do, you go in a wait state and say, okay, now I wait for the payment received event. And that code is exactly the same like the code I already showed you. So you could make that combination very generic. It's very easy. And then you have a state machine. Then you can do lovely things like, if that takes longer than some time, I want to do something. And you can have monitoring, like, hey, why the heck is that not continuing? Ship goods, what's happening there? So I can have a look and can say, okay, well, I want to go in a dashboard of this kind of whatever workflow engine I use. And I see, hey, there's one instance. It's currently waiting here for the goods to be shipped. So it's still there, it's waiting. I can even look at the timestamps and see how long it's waiting. I can create incidents that they're piling up there, for example. So if I do another one, just do another order, like do a couple of them. If I refresh that, they're all piling up there. So I can create incidents that there's nothing happening there. Why is that? In this case, it's very easy. I haven't actually started the shipment service yet. So as you probably have seen, there's no shipment there. So we want to start that. So let's start the shipment, the orchestrated shipment. Where's shipment? It's too late for me. Where's shipment? Shipping, yeah, we're shipping. Higher. That's the correct one.
Even higher.
Where's my
Even higher.
Cannot orchestrate.
Oh yeah, how did that happen? Oh no! Oh yeah, I see it. It's too late for me to spot these kind of things. Now it's there where it should be. Sorry for that. But I'm happy that you're still with me. That's cool. Now I started the shipping. And as soon as I do that, if I go back to my monitor, I should see, oh, now this moves on. It's shipped, order complete. And I can see the same thing here. Now this pile of waiting things has basically gone away, and I can see that all of these things are now walked through correctly. I can see a lot of statistics and these kind of things. So that's pretty cool actually. And the thing Martin showed earlier, and I have to make sure to kill the right service. I killed the order service for a moment. Whenever I kill the order service, by the way, that's the thing which is often like the critics of that approach. Now the order service is gone, no, nothing happened. But I normally argue like independently of which service is currently dead. If some service in the chain is missing, it will not be fulfilled anyway. And in this case, the order service is missing. Okay. But what we can do, and that's actually pretty cool, we can change the flow. And let's assume, I think you had it in the slides, right? Changing the order. So let's change the order. Let's do it in a nice and confusing way. And it has to look good. So this, I think this way, right? Yeah. Yeah. If I switch them, it would be easier, but not that nice. No, that's awesome. I think that should work. And the thing is, as soon as I restart that, orchestrating order, That basically just does a main build and then running the Spring Boot application. And that comes up relatively quickly normally. Let's go back to my console here. The first thing you see, as soon as it's up, is a live form. Oh, that's my one. It's yours? If I have one. Where's mine?
There's one down there?
Yes.
This one.
Awesome. I thought I'd take the opportunity, but now it's gone. No. So let's sign in. And the first thing you see is that I'm still looking at the history with the same process model. So if I still have running instances, they will keep running in the old version, but I also have that new version deployed, which looks much nicer actually, and which already should have executed one instance actually. Let's see. Let's make another order just to make sure. And then we should see something here actually. Yes. So this is now executed like in the new version. And this is actually, this is a hard problem in reality if you do it without that orchestration logic, because you always have events flowing around in the whole microservice universe, let's say, and you have no idea where they currently are. And if you want to switch that order, that's a really hard problem to deploy in production. So that's I mean, still, if you hard code that orchestration logic, it's still better than not having it. But having a workflow engine, it's much cooler. Anyhow. That's, I think, that what I wanted to show here. Yes. Next thing. Question. Raise your hands. Who's doing like a message-driven thing, asynchronous event communication thing? Okay. Who's doing REST communication or gRPC? Oh, that's half-half. Okay, then Munich is pretty good actually, because normally it's like, let's say 80% REST. That's my, if you go to a Java conference, it's 80 to 90% of the people are doing still like a lot of synchronous REST calls. So what I normally do like as a second thing is when I look into the payment service, and that's what, by the way, that's what Martin said earlier. So I have the order service which runs, in this case, a Camunda engine. It's on 8091. And I have the payment service. It's on 8092, so it's a different microservice. And that also runs a Camunda engine. That's by coincidence, just because it's like a cool engine. But that's the same thing I have, if you look back here. I have the order service, for example, also with using Zeebe, so a different workflow engine. And so you can really make a choice per service. So there I also have the payment. I can look in the payment and see what's going on there in the payment. And the same thing. For that nice little demo, I normally take a shortcut path through the payment. I have this payment service actually also using a lot of REST communication in order to show like long-running things are also very important in REST architectures. So in order to do that, what I do first is I shut down all that stuff. All my microservices are gone, all the hardware. So there it is. I definitely shut down Kafka. That really slows down my machine. So, and there we are, nice and clean. Now I start the REST thingy. Doesn't come on now. So we do for the moment. And what I do as well, I start what I call like the Stripe fake service. So I basically, this one is like a credit card service you probably would just leverage. It's just a fake service where I can send requests to. And I started the payment service, which I explain in more detail in a second. But this time I use REST in order to talk to the payment service. And it's actually very easy. So the first thing I do, let's see if we get that on one screen. I have the payment service, probably there. I have the Stripe.
Don't you need to do something there?
No.
What do I need?
Answer the question. Slow and normal.
In a minute.
Okay.
That gets important in a minute, but for the
Okay.
moment I don't care. Let's quickly do that. So, should work. more or less. So whenever I send something to V1, it goes to the payment service. That could be like in the earlier example, that would be a command message via Kafka. In this case, it's a REST request. And this one calls synchronously via REST the stripe fake. I could show you the Java code, but I show you the Java code. Actually, it's so easy. And you probably have programmed that yourself as well. If you're in Spring Boot, it looks like that. I have REST controller. I map that to a path. I don't do interesting stuff here. Then I want to charge the credit card. What is it in Eclipse? F3. Charging the credit card basically means I want to create a request object, use the REST template, and Spring everything as a template, to post to a certain URL, send over that request, get back a response, and then probably get some data from the response. That's what it is. Very easy, right? REST. Who has programmed something like this before? Just to know. Okay. So this is what I have. I do that. It should actually work. Yeah. Charge on credit card. That's awesome, right? Cool. Could do the whole year. Now we come to the slow. No, I basically can change the service to behave slow. That's basically to simulate that the network is probably slow or not really in a good shape. What happens? Test question.
Timeout.
Timeout was one thing. What's what?
The process starts.
So what basically happens? It's a random delay. It's 29 seconds at the moment. So it basically, what you can see here, it's still like the point is bad. It's blocking. It's blocking. If I wait or talk for 29 seconds, I will see that, and then I will get a response, but that will take 29 seconds. And that's a bad thing, actually. That's a very bad thing, especially in microservice architecture. That's one of the main problems we currently see if we have these call chains of synchronous REST requests. It adds up all the latency. It adds up, and then you normally, like in this case, it came back 29 seconds. 29 seconds it's slow, but it's probably still okay. But normally, if you then start running into timeouts, you even don't get a response, but you're blocking all the threads here, and they cannot do like real work. So that's something you should definitely avoid. How do we avoid that? Yes, question. It's a hint, it's not a state machine, it's not Camunda.
Async call.
It's an async call, yeah, that would be probably one possibility, which I think is a good one, but if we stay with the rest, what do you normally do? Do you know anybody like Istio service meshes? Yeah, circuit breakers? Okay, I see a lot of nodding. So what you normally do is you add circuit breakers to this kind of thing. So V2, quickly go into code, V2, basically the same code. The only thing I changed in the charge credit card is I wrapped it in Hystrix. Hystrix is from Netflix, one of the circuit breaker libraries which are quite common in the Java space. So now the behavior changes a bit. So V2, what happens? It's still slow, 33 seconds, but I get back a response much faster. Like in this case, okay, it's an error, yeah, it's an error. But that's important because it doesn't block my threads here. It's very important to have that. But in this case, and that's what this is kind of like most of the people start to know in the microservice universe. That's already pretty good. But that's the same problem actually what we discussed earlier, or what Martin discussed earlier. That's, in this case, it would be a much better design if that payment, like what you said, would behave asynchronous. Would say, okay, I cannot reach a credit card service, but that shouldn't affect my client requesting the payment. It should be like getting long running and say, hey, okay, credit card is currently slow. Don't worry, I take care of it. And then I talk to you back whenever I have it. And that's something, what I call also a stateful retry. So the payment service actually should retry the credit card charge. Like simple retrying could be also be done with the service mesh. But if you want to wait for like 30 seconds, a minute, 5 minutes until the hiccup, the network problem goes away, That's not possible with these kind of technologies. And then you can start using state machines. And that's what I do here, for example. So I have my V3. It uses an auto-wired Camunda. We already saw it. And then I define a workflow. And I intentionally use Java code here in order to define the workflow. So you're not forced to use graphical modeling in order to define workflows. You can say something like, I want to have an executable workflow. It starts here with a start event. That's something we need. But then the first thing is we have a service task. And then we attach logic to that service task. In this case, it's a so-called striped adapter. That's actually that's an expression language, and that refers to a spring bean, which is defined here. So this code, if I go into the code here, it's exactly the code we had in the earlier version. So I haven't changed that at all. I just moved it to that class, which I then can attach to my workflow. And then I'm basically done. And what's now the value of that? Now I have the state machine again, and now I can attach like retry logic in this case, and where I say, okay, retry 3 times with a delay of period time 1 minute. And I could even like do more things. I could retry that for 3 hours, for 5 hours, whatever I want to do. And then the behavior changes, like in this case, I go to V3, send it, and you see it's still slow, 16 seconds. I still get an exception, because I mean, history still cuts off, so it cannot make the call. But you will see actually a retry in the background. That's an interesting part. We can probably quickly also look at that. It's now 8100. So we're seeing currently one instance basically waiting to do the stripe call. If the stripe service comes back to normal, if the stripe service comes back to normal and I still have retries, that will heal itself. That's pretty cool. But I don't want to wait for that. If you want to wait for that, I don't. But no, it's too late, right? One thing which is interesting here is if I look at Postman, I changed the return code actually to 202 accepted. So I don't get a 200 back. 200 means, hey, I retrieved the payment, here's the result. That's the atomic operation. But now I'm on 202 accepted, which basically means I got the request, I call you back. And that's a much better design of that API, because now the service can be long run. And it can do whatever it needs to do until it's really sorted out that we get the payment. But as I discussed that so often, like I cannot count the hours. I discussed that last year with like domain experts, but also developers, like which normally say, okay, but this is not going to work. I need a synchronous response. Like for example, in ticket booking, I had it very often. I need, if you go through the ticket booking process at the very last page, you want to have that PDF ticket like open up that you can print it right away, which I personally don't. I don't want to print any ticket anymore. And I mean, if the decision is getting a synchronous error message right away, or getting an asynchronous ticket later on, it's easy to decide. But that's the code is homework. The code for V4 is homework, but V4 does exactly that. It does 202 accepted if the service is not behaving like it should be. But if I do it like normal again, so if everything is clear, I get a 200 okay. And and what's also important, it's not slow. Just because I'm using a state machine doesn't make it slow. So I can get like a synchronous response, and whenever there's a problem, I switch back to an asynchronous default. Okay, that's a very, very helpful behavior actually. Does that make sense so far? Awesome. So that's again like usage of the state machine, and this is what I call, by the way, potentially long running. Because it's not always long running. Very often it's like I directly get an immediate response. But if there's a failure, I probably have to switch back to long running, to asynchronous. Okay, I could talk about that for ages, but I have like a third demo, which is the most risky one because it involves Kubernetes, which basically involves my internet, and that's the risky part of it. Are you still up to see that one? Yeah, okay, awesome. I have one warning. I have a couple of slides in order to introduce that, but I thought it might be worth it. So, what I used so far is the Camunda workflow engine. So the Camunda workflow engine is what I have here on the slide, a traditional workflow engine. There are a couple of them, even much more. Martin had more in the slides, which are basically like this, that you have the engine and it uses a relational database to store the state. Because if we are long running, we have to store the state somewhere persistent. And using a relational database is, or was the way to go a couple of years ago. If you look at how far you can get with that, is that really performant, like relational database? There are great studies. I don't want to bore you with all the details. You can download them yourself. One university once did a study of performance of workflow engines. This is how they did it. They made a couple of like, these are the patterns, and this is how different workflow engines behave. I give you the summary, and they said, in general, we may compute the Camunda. You can read it yourself. It's not from me, it's from the study. So that's science. That's science. I'm not a big fan of science, but that's science. That's cool. I really love that. If you want to have like an idea on what that means, I actually have a new notebook by now, but at this time was a T460, so it's like a typical consumer notebook, nothing fancy. And then I just run it like a test. That's not science. But it gives you a number, and that was roughly like 180 instances per second. That's an idea what you can do with that. It's okay. I mean, we're having, for example, Zalando as a customer. Every Zalando order is shipped over the engine. That works pretty well. They calculated, there's a tweet about that, that they can run their potential growth of the next 10 years on that architecture, which is okay. So that's pretty cool. And you can still scale it in a way that you can have multiple engines meeting on the database, that you can do some sharding. So there are ways of tuning that. So actually, that's was for a long time that was pretty fine. And then we discussed that with a lot of customers and a lot of use cases, and bigger customers and bigger use cases. And once I remember that exactly, that moment when we got this, like, I think we even said something like scalable like hell or something like over exaggerating. Okay, but this is not scalability. And we already started thinking about that quite a while ago. And now we have use cases where we are asked, okay, this is awesome technology, we want to use that, but can you really scale up to like process 200,000 trades per second? Or if we have that REST request I just showed, can you do like 30K requests per second for REST requests with a very low latency? Can you handle that with these kind of technologies? And the thing is, no, we can't. We can't. So the relational database is a bottleneck, and it doesn't scale that well. We come quite far with it, but there's, and we actually get, oh, thank you, no, not that far. We're getting quite far with it, and actually much further than most people think we can do with this kind of technology. But we don't get to these low latency, high throughput use cases. So don't use like a Camunda engine with a relational database underneath for these. That's really hard. We have a couple of customers going like this with Camunda, but then you have to tune it on yourself. And what we currently do, and that's a quite interesting project actually, we're teaching workflow automation to really go into that space. And that's the what Zeebe is. So the Camunda workflow engine, that's, let's say, the mature product, that's what everybody is using out there. But we're doing an own R&D open source project called Zeebe on zeebe.io. So check that out if you're interested. And what we have there, just a couple of measures, again, not science, but to give you an idea. This is the number of basically events we can process in Zeebe compared to the events we can process on the same node with Kafka. So it's not about being faster or slower than Kafka, but it's the same order of magnitude in scalability of what Kafka can do. This is we do a couple of experiments with a lot of like big EC2 instances and then scaling it up. And there we can see that we really can scale horizontally, and we can run much more than even 1 million workflow instances per second. That's not a problem. And you can, you can even like continue scaling. But that's pretty awesome what you can do there. I don't want to go into all the detail how it's done. If you're interested in the details how that's done, basically ask me afterwards. Let me give you like 2 or 3 hooks, like mental hooks. So we're having this, we don't call it workflow engine anymore, we call it broker. And the broker basically works on an event stream. And then we have a lot of things what distributed systems like Kafka or also Cassandra have. We're having like leaders and followers. We're having a kind of a raft protocol between them. And yeah, I think that's kind of, at least to get the idea of if you're interested or not, then basically ask me. And that really scales up. That's pretty cool actually. We'll have the slides afterwards, so I have something in the slides for, yeah, what's happening here? Let's do it the old way. Hey, even the old way doesn't work. There we go. I stopped Kafka. Normally Kafka is doing strange things. Don't want to thank Kafka. So if you look at it, like for example, like very simple workflows can be basically also expressed as commands and events like, okay, hey, start that workflow instance for me. Okay, then we did that. We started the workflow instance. We basically, by the way, we walked down the first like error, like sequence flow, and we entered an activity, and so on and so forth. So you can express every workflow as a series of events and commands internally. And then if you do it clever with leader and followers, I don't want to go into details actually. Then you can process that in a way which is very cool. I think that's for the moment. It's a quarter to 9, right? So we keep it to that level. So it's currently a tech preview. If you want to do something with it, best talk to us. If you want to really play around with it, wait for, and that's a pro tip for me, wait for 0.12, which should be around mid of October. That's a pretty cool version. That will be good. And we are working towards a production ready state end of the year, basically, or beginning of next year. And we're currently working with a couple of pilot customers in quite huge scenarios, actually. So that's really interesting. So let's do the last demo of the day. And the last demo of the day, I want to do with Zeebe. What's going on here? It's interesting. I think, oh, now it's going backwards. I don't do anything.
It's asynchronous.
No. That's kind of a freaking effect, actually. So, what we can do? Does anybody have the same pointer? Doesn't it? Like we did in school with the No. The next possibility could be the touch screen. The touch screen is sometimes weird. Let's try this way. Last try. So, awesome. Good. I want to show you one last idea, which is actually quite interesting. So we are having quite some customers currently, which already moved on like the microservice way, and very often embrace choreography a lot. So they're having a lot of events flowing down back and forth on Kafka. And then one interesting thought is that in the first place, it's normally hard to directly like start doing some orchestration or some managing part because they already have something. And then we can start with something, what I call tracking the flow. So the first thing could be just to listen to all the events on the bus. Yeah. And that's what I do now. So I have, again, Kafka, I have my services. In this case, they are choreographed. So For example, the payment listens to, oh, order placed, then it retrieves the payment, says, hey, payment retrieved, and so on and so forth. You see that in a minute. And then I can attach, like the workflow engine to it in the first place, just basically to listen to all the events. And then I have like a very simple workflow like this. I just check where I'm going. But this allows me, like in the next step, do I have the slide here? Yeah, okay, awesome. In the next step, first of all, to leverage the information, like all the statistics, all the operations part, seeing if something is stuck in the workflow and so on. That's already something I can do. And, hang on a second, and I can start also doing things like adding timeouts. That's a problem we see very often in these architectures. You have these events going on, but you have nobody who really recognizes if something gets lost. And that's very easy to do that, actually. Let's jump into code. Or not that much into code, actually. Kubernetes. So, actually, I just use Kubernetes actually to not being forced to restart everything on my machine, which I'm not sure if it might have been faster than the internet at the moment. It was okay during Martin's talk. No, the internet is going to bed. If it doesn't work, it's not that much you miss. Ah, there it is. So, I have, basically now don't have these command lines anymore, but I have the, basically the pods in Kubernetes. So I have Kafka, Zookeeper, that's Kafka. Then I have the checkout on the monitor, that's what I had earlier. And then I have inventory, payment, and shipping. And this allows me to do the same thing as early on. I have my monitor, let's see if that works. Yes, awesome. Then I have my place your order, I do it. And woohoo! In awesome light speed, it's processed.
I think we just have Edge.
I had 3G actually, but anyhow. Yeah, but this is now in Kubernetes, it's enterprise software, so it's... but anyhow, now I have the order placed and then directly the payment received because there's listens. Now I have like a simple event chain. And what you can see, by the way, I don't go into the details, but if you want to play around with it, you're at home, you see that I have much more data in the events now because I have to transport some of the data from here to there. But that's not what I want to look at. So this is what I have. That's my event stream. And the next thing I can do actually is what I also have in the background. I have Zeebe. So Zeebe is already started. So I can basically go to Zeebe, look at the web console, deploy new flow, and that's the flow. Hello. Oh, that tries to be crazy. Not sure what's happening here. Open. There. That's the flow I just showed you. So I can basically just deploy that. Deploy it. Let's see how long that takes. Yeah, there it is. And then what I can do, and that's actually pretty cool. Who is using Kafka? A couple of people. So what I did is I used a Kafka connector. Kafka Connect is the basically the way to also like stream data from or to JDBC to Elastic or to whatever. So I created a Kafka connector in order to stream all the events to Zeebe. And this is how it looks like. It basically just have a, always get confused by sync or source. Yeah, this is basically what I want to have. So I basically say, hey, everything from the flowing retail topic in Zeebe should be, in Kafka, should be sent to Zeebe. And then I basically specify how the data is correlated. So it looks into the payload, checks if there's a trace ID, if there's a message type, and then correlates that to Zeebe. So it's just that configuration I need. And then I can start. Where's my console? I have that tracking Zeebe part. That's here. I have to start it. I wanted to start it actually. Help install. name, flowing retail track, for example. So what does Helm do? Helm basically just provisions the thing on Kubernetes. It just starts Docker image. The Docker image has a Kafka connected. Very easy. And if the internet is with me, it should actually show up here sooner or later. It's there. Now it's on Kubernetes. Now it's Google who starts up the machine, which normally also takes a bit. But sooner or later we should have it. Yeah, sooner or later we should have it. Gives me opportunity to trick something. And we're almost done, by the way. You can already make up your mind if you have questions. Hello, Google. Oh, no, I shouldn't say hello, Google Russian. So, that's there. So if I go back to the monitor, what I should have in the instances, I should have the instance there. Too bad. I don't want to wait for it actually. It should, there it is. So that's now just reading all the events from Kafka and starting this workflow. And now we can start adding the dependent stuff like doing some timeouts, probably even going into the orchestration way of adding in more things. So that's basically the ability to start here, and then we have quite some customers moving slowly to the direction where they really start to manage the flow of this kind of things. Okay, awesome. And then in the reality, we normally have a lot of hybrids of all of these kind of things. That's my closing slide. So from my personal, what I see the customers doing, they're not only trying to do these like nice choreographies, right? These event things, very nicely decoupled, and then there's this nice dance emerging out of that. But the reality is that it's really hard to manage. So you should think about what you're doing there, and you need to balance that. You really need to balance choreography and orchestration. So that's the same here. I'm out of time. Thank you very much. There are a couple of references. If they keep there on the slide, let's see. Thank you so far. We'll do a couple of common questions.
Yes. So,
Awesome.
great talk, by the way. Great talks. Enjoyed it very much. So now we have time for questions. Yes. You need to turn the mic down because currently this is very.
This is a very simple question. The Camunda cockpit and the Camunda modeler part of the open source or the premium version?
No, it's both open source. We have in cockpit we have a couple of features which are enterprise only, but the basic cockpit and the whole modeler is there. So our goal is always also with the to allow it to run successful projects also on the open source edition. It will be a bit easier with the enterprise.
And it is also allowed to use it in commercial.
Yeah. It's a Apache license, so you're basically free to do whatever you want to do. That was the question.
No, wait.
Oh, for Martin. Martin is also still here. Run, Christian.
And it's not so much a technical question, but more like an organizational. Because I worked at a failing Camunda project once. Because we had this the requirements changed very often, and we thought it because the product owners kind of were not happy with the fact that when they had some changes, they needed to wait for the next sprint and the next deployment and so on. And then we thought, let's use something where they can just model the process and just instead of like having Java code that calls the Java methods, we just used the Camunda model. And it turned out that if you don't know exactly what the Java methods are doing, you cannot create the model.
That was a surprise.
Only developers were able to actually model the business processes, and then like instead of Java, they just needed to do it in KKN, which took even longer than before. And so I think, is there some kind of best practice, like who actually does these models and what he needs to know?
Yeah, I mean, it's typically different depending on the organization, so the roles are different depending on the people who are doing it. But normally it's a bit like business analysts like sketch an idea of what they do, probably in VPN, probably not. And then normally IT does it, and then at least like business analysts or also domain experts are able to read it. And I think that's one very important thing, because then you can also like point to things you want to change probably in the next iteration. So my goal would not be that like business does it on its own and draw all the stuff and it works. That's exactly what we don't want to have actually, and what's never worked with VPN. But I'm fine with developers doing it, but business should be able to read it, and basically it should be still like something to discuss. And that's what I said, I haven't really had that in slides. Biz DevOps, so that's the biz dev part, like the alignment between business and IT, like development. And then the operations part, and that's the part we have in Cockpit. And that's again another role which is normally able to read the BPMN model and see, okay, here it's stuck. Here, that was the stack trace probably, this was the data attached, this is how we got there. So there are a lot of things they can see in there. And that's another like big help. But my goal would not be that the business does it like on its own. Make sense? Cool.
Questions could also go to Martin. You are waiting. Okay. Double features make people double features make people tired.
We're still here, there's still beer.
Yes, so we still have pizza, we still have beer. Thank you very much for those. And the recording is still running, so I will mention Rio with sponsoring the evening. So in order to make Rio happy, you know where the pizza and the beer is. And we don't do workflows yet, but we have the Kafka part in there, and we have events, and we are thinking about commands. So it's also a fun place to be. Thank you very much. Enjoy the rest of the evening.